So we're going to get into the study of bonds. Right? So when you look around, of course, you know everything's made up of elements or atoms. Okay, but when you look around, you're only seeing usually about 20 atoms, okay, different types of atoms. Okay, but they can form all the different combinations because of bonds, okay, forming molecules. All right, so we're going to get into the study of bonding. There's actually, bond is something, a force that holds two atoms together. And actually, there's just two major types of bonds, which we're going to look into. Okay, ionic and covalent. Okay, next week, we're going to look into covalent bonding. This week, we're going to look at ionic bonding. Ionic bonding occurs between a metal and a nonmetal. Okay, it's due to a transfer of electrons, whereas covalent is when you have a sharing of electrons. But regardless of the type of bond, okay, the basic concept is all atoms want their outer shell filled up with electrons. Okay, so they call that the octet rule. Okay, octet because it's usually 8 electrons. Now, not always. Okay, the very first level, okay, only takes 2. Okay, so this is a Bohr model with the nucleus right here. Oops. With protons and the neutrons in there. Okay, but the electrons is what we're concerned with when we have bonds. Okay, so in the very first level, it's filled up when you have 2 electrons. That fills the first level. After that, every outer level is 8. So if this atom has 10 electrons, it'll do this. Okay, and then that's satisfied. Okay, if it adds another one, okay, it's not so happy. It either wants to fill up that shell or get rid of some electrons. All right. Okay, so that's the basic rule. It's called the octet rule. Okay. So let's see how basic ionic bond will form. All right. So take a metal called sodium. Sodium has the atomic number of 11, so it's got 11 protons. Okay, and it's got 11 electrons. Okay, so if we fill in this shell, it's going to take 1. This marker is not working very well. Let me grab another one. Alright, so it's got 1, 2. Okay, that fills up that level. Then you have to bump out to the next one. So then 3, 4, 5, 6, 7, 8, 9, 10. That fills that shell. Then you put one more out here. Okay, and then that's 11. Okay. Okay, but now the problem with this is that its outer shell is not filled up with electrons. So you can see it needs 7 more. So for it to satisfy that octet rule, what it wants to do is either gain 7 more or lose 1. Okay, so obviously it's much easier for it to just lose that 1, get rid of it. And so now it's happy. It's got its outer shell, which is this second level here, filled up with electrons, so that makes it stable. Okay. So, but now you still have 11 protons in the middle, but now you don't have 11 electrons, but you have 10 electrons. Okay. What that does, you have 10 negatives, 11 positives. That's going to give this sodium a plus charge. Okay. So we say that this sodium is a positive ion. Okay, or it's a cation. Okay, so contrast that with chlorine, okay, which sodium will combine with. Okay, so chlorine, 17 protons and 17 electrons. So we fill those in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then 7 more. 1, 2, 3, 4, 5, 6. 7. So in chlorine's case, which is a nonmetal, it can either lose 7 or gain 1. So it will tend to try to grab or gain 1 more electron. Okay, so that's going to give it no longer 17 electrons, but 18 electrons. And you know where I'm going with this. So chlorine has a minus charge, or a 1 minus charge. Okay, so what can happen is you can get this electron, which sodium loses, can be gained by chlorine. And what that does, I'll show on this next one, sodium plus, chlorine minus, and we know that opposites attract. Okay, so that forms a bond. So we call that an ionic bond. Okay, right there. Okay, it's a pretty strong bond. Okay, so that's how ionic bonds form. Okay, now that brings on this concept of oxidation numbers. Okay, oxidation number, or the number of electrons lost or gained. Okay, so in sodium's case, we have Na. Okay, it lost one electron, so it lost one electron. Okay, so we say its oxidation number is 1 plus. Okay, because it's got that 1 plus charge. Chlorine, on the other hand, gains 1 electron. Okay, so we say its oxidation is 1 minus. Okay. If you had something like magnesium, which loses 2, it would have an oxidation of 2 plus. If you had something like oxygen, which gains 2 electrons, it would have an oxidation of 2 minus. Right. So that's going to tell us how to combine atoms having these different oxidation numbers. Okay, so when atoms combine, they have a certain formula. The formula tells you the number and the type of atom. Okay, so you're familiar with a lot of these, like for example, water is H2O. Okay, so that means there's 2 hydrogens and 1 oxygen. Okay, so you write that as a subscript. One we just did with sodium and chlorine, it's sodium chloride. It's a 1-to-1 ratio, so if the number is 1, you don't put little ones down there, they're assumed to be 1. Right? And then here, this is glucose, which you guys burn for energy. Okay, C6H12O6, so it's a bigger molecule. Okay, but again, that formula tells you the number and the types of atoms, so and the ratio in which they're combined. All right. Okay, so we already talked about this. Oxidation numbers, or the number of electrons lost or gained. Okay, we already went over that. Now here we go. How do we write the formulas? So here's the rules for writing formulas. Okay, so the formula gives the number and types of atoms. Okay, first of all, you write down the positive ion. That's going to be the metal. Okay, the ones on the left side of the periodic table, because they tend to lose electrons. All right. Then you write down the negative ion. Okay, so the non-metals, and then you combine them so that it equals 0. All right, so let's give an example here. Okay, the basic rule here is the sum, SUM, of the oxidation numbers will equal 0. All right, so we'll try some binary ones. Binary just means there's 2 elements involved. Okay, so if you look up magnesium, okay, magnesium is Mg for formula. And it's a 2 plus charge, okay, because it loses 2 electrons. Fluorine, its symbol is F, and it tends to gain 1 electron, so it's a minus charge, or you can go 1 minus. You don't have to put the 1 there. Sometimes people do, sometimes they don't. Okay, so let's just do that. If there's no 1 there, it's just assumed to be 1. Now in this case, they have to equal 0. So for this to equal 0, you need 2 F's to equal that 1 Mg. So this formula would be Mg F2. You write that 2 as a subscript. That means there's 2 fluorines are needed to balance that 1 magnesium, because that's a 1 minus and that's a 2 plus. Okay? So that would be the correct formula. Now for naming, when you name binary compounds, you do the full first name, so it would be magnesium, full positive, full of the metal, and the second word would be the root of the negative, so that's the root of fluorine, okay? And then you always add IDE in binary compounds, okay? So just think about it, magnesium and fluorine, you don't call it magnesium fluorine, you call it magnesium fluoride. So those are binary. Now there are some atoms which are called polyatomic ions. Okay, they're groups of atoms which act as one. Okay, so there are 2 or more atoms that are actually combined covalently, which we'll talk about next week. Okay, but they act as 1 ion. All right. So in this case, you do the same rules. So aluminum is Al, and if you look in the periodic table, it tends to lose 3 electrons, so it's got a 3 plus charge. Carbonate, you have to look that up. It's CO3, so a carbon with 3 oxygens, and it's got a 2 minus charge. All right, now you got the problem here is, what do you do? Well, these numbers have to add up to 0. Okay, so you have to do something so to make that they balance out. Okay, so what you do in this case, you figure out what's a number that they both can go into evenly, okay, and that number, of course, is 6, and you make them each equal to 6. Okay, so to do that, you go, well, got the aluminum. I need 2 aluminums to equal 6, so it'd be Al2, and that's going to give it a 6 plus charge. And then the CO3, which is a 2 minus, you need 3 of those. So you put a 3 there. But now you got a little bit of a problem because that looks like CO33, okay, which is not the case. Anytime you put a number other than 1 on a polyatomic ion, you've got to put parentheses around it. Right? So that's the one little difference or little wrinkle that you need to use with polyatomic ions. Okay? So 2 aluminums and then 3 carbonates, and that makes that's the correct formula for what you would call this aluminum carbonate. This is even easier to name. You just go full of the positive, so it'd be aluminum, and then you use the full of the negative too, so it's just aluminum carbonate. Okay? So you know, if you see a name like aluminum carbonate or calcium sulfate, okay, if it doesn't end in IDE, it's going to be a polyatomic ion, so you can identify it that way.